Okay, this should really be NPV part 2, but I think I'll go right through to internal rate of return, and then we're pretty much done. But this is an important chapter. It's your last one, so now you know what you need to study for the exam, okay? So the profitability index is a way to help you rank the projects. And if you take the present value of the net cash inflows, excuse me, and then divide that by your initial investment, it gives you the return for every dollar invested. Okay, and the only reason why the reason why it works is because these are all in present value dollars. So here's an example. We've got 3 projects. Now the present value of the net cash inflows, all right? So the present value of what you're getting every year for it is here, 150, 238, and 182. And then here's the initial investment. So for project A, I'm investing 125 to get 150. So my net present value then is 25,000. To figure out the profitability index, I'll take the present value of the cash flows, 150, divided by the initial investment, and that gives me an index of 1.2. So I get $1.20 for every dollar invested in this project. For project B, my net cash inflows are 238, divided by the investment of 200. For project B, I'm getting 1.19 cents, okay, $1.19 for every dollar invested. And finally, for project C, sorry, my present value of my net cash inflows is 182. I divide that by my initial investment of 150, and I've got a profitability index of 1.21. Okay, so it's a handy way to rank them. That's what you would use it for. And now we've got one other thing that we'll do, and we'll do this in our problem in class. But to discount the residual value, if you've got a project that's going to be worth, say, $500,000 in year 5, and then the project's going to be over and you're going to sell this asset or whatever, that $500,000 can be discounted to present value, okay? And it's discounted as a single lump sum, okay? So you discount the residual to its present value when determining the total present value of the project's net inflows. So on this one, this Allegra expects the smartphone project equipment to be worth $100,000 at the end of its useful life. So let's take a look at that. Here's my table. Okay, a nice organized spreadsheet really helps you get through these. So the present value of my annuity was 3.43. It's going to pay $305,450 each year for 5 years. So my present value was $104,810. Okay, now here's my residual. The project's going to be worth $100,000 at the end of year 5. My factor for a lump sum is 0.519. Okay, see, the annuity is greater than 1. The lump sum is always less than 1, always. So that's the present value. That is $51,900. So the total present value of my cash inflows is $1,001,510. So now the net present value is $100,510. Okay? Okay, let's keep rolling here and wrap this up. The internal rate of return is the other one that we use, and that is the return that the company can expect to earn by investing in a project, and it's based on discounted cash flows. And what you do is you set the inflows equal to the outflows. So the inflows times X, the discount rate, is equal to the outflows. Okay? And I'll show you how to do that. The higher the internal rate of return, the more desirable the project is. And it's just another way to rank them. Sometimes you'll get contradictory information between a net present value and an IRR. You really have to take all these methods into consideration and figure out what's going on to help you make a good decision. Okay? So here's an IRR with equal net cash inflows. That's all you're going to get from us. You've got your initial investment divided by the amount of each cash inflow will give you your factor. Okay? So you take the factor then and you look it up on the table, and come back with whatever that interest rate is. Okay? So I know this probably, well, we'll have to do a problem and I'll show you how it works, okay? But that's the internal rate of return. And if you can't remember this, to me, it's the amount of each inflow times the factor is equal to the initial investment. And you're looking for the factor. Sorry. And here's an example of an IRR. Here's the, let's see. Well, you know what they did was they just worked it out. And here's using 16%, and here it is using 18%. Okay, and they're just using trial and error, trying to find the rate that's closest to. So here it's kind of close to the 18%. But we've got a better way to do it, and what you need to do is understand the concept and basically how to do this. Okay? And here it is with unequal net cash inflows. You've got to use a trial and error process and just keep trying it out till you get close, and then at the end you use interpolation to find out what the actual percentage is. I honestly think it's way too much work, and this is for a computer to do. And then the last thing is to comparing and contrasting the methods that are left here. Make sure you take a look at this, that you can, after you practice them for a while, then come back and let's look at the slide. Maybe we'll look at these on Thursday and apply it once everything's in your head. Okay.